Hello class, welcome to this chapter 8 handout 2 answer video. Let me get my screen going here with you and we'll jump right into this. Hopefully, this ain't all my videos, you've had a chance to do this beforehand, but if you're just coming into it cold, that's fine. We'll work through it together and hopefully by the time you leave here, you're gonna have a great understanding of what's going on. So we're gonna start here with Jack's Lumber. Jack Lumber gets some trees in, 8,000 of them to be specific there. It's processed into rough logs. We can decide to sell those logs or process it further. So here we have a sell or process. So we process it further. We can use it to refine lumber. Sell for a per unit price of $4.95, or we can take it into 800 feet of lumber. Also, an additional cost of 15 cents per foot. Already sold with 75 cents reward. Okay, so we got all our information here. What is the contribution margin to income from selling the logs for log cabin construction? Well, if we sell it for construction, we are going to sell for $495 each. We're going to sell 8,000 logs. $3,960,000. That would be the contribution margin to income if we sold the logs straight for cabin construction. However, what if we process them further? Alternatively, each log can be processed into 8,000 board feet of lumber. So first we have 8,000 logs. We need to multiply by 800. So 6,400,000 board feet of lumber. Okay. So what would be our income from this? Contribution income from this. Okay. I took this number and I multiplied it by 60 cents. Okay. That's because if we sell it for 0.75, it costs us 15 cents. So really, we're making 60 cents on each foot, okay? And when you do that out, you get 3,840,000. Okay, if you wanted to check that, you could take the 4 times 0.75 minus you get the same answer, no matter which way you do it. I just took the shortcut here and just knew that if it's going to cost 75 cents, but cost an additional 15 cents, I'm only making an additional 60 cents by processing it further. Okay, but we are going to do those. We want to sell those logs. Okay. It's actually $120,000 better for us to sell them instead of process them further. Okay, so you just want to work out, you got to read through all the information, pull out all the relevant information, plug it in here, and make the best decision you can based on the dollars. Okay, so comfy fit. We have 2 types of sweatshirts. Hey, we have the swoop. And we have the Rufus. I guess it's Rufus, not Rufus. Okay, contribution margin per unit. We have 5 and 15. Regardless, we must feed through a stitching machine to affix the logo. The firm leases 7 machines and each provides 1,000 hours of machine time per year. So we have a constraint here. We have 7,000 hours of machine time. Okay, the swoop sweatshirt requires 6 minutes, the Rufus 20 minutes. And then he gives some things about rounding, which actually is kind of funny because it doesn't really come into play here. Okay, so what is the contribution margin per hour of machine time for each type of sweatshirt? Okay, well, our swoop here, we have a contribution margin okay, of 5. We can do a sweatshirt every 6 minutes. So how many could we do in an hour, right? We could do 10. Right? If we could do one every 6 minutes, 60 minutes divided by 6 minutes gets us, we could do one every 10 minutes. So we have a contribution margin per hour of 50. Where on the other hand, for the Rufus, we have $15 contribution margin per unit. We can only do 3 per hour because it takes 20 minutes each to do them. So we have a contribution margin per hour here of 45. Okay, so there's our contribution margin per hour. So what is our optimal amount of sweatshirts? Well, it doesn't give us a demand quantity, okay? So we want to make as many as the swoop sweatshirts as we can. So if we have 70,000 hours of machine time, we times that by 60 to say we have 420,000 minutes. It takes 6 minutes to make one swoop sweatshirt, so we divide by 6. And we can make 70,000 swoop sweatshirts. And then the final question, what is the total contribution margin earned for the optimal mix? Well, it's $350. We can get 70,000 of the swoop sweatshirts, $5,000 contribution margin each. So 70,000 times 5, 350,000. But what if the max demand for the swoop was 50,000 sweatshirts? Okay. Well, then we can do something different, okay? So we still have, kind of make my little spot where I'm working in here. We still have a total of 420,000 minutes, but if we're only making 50,000 of the swoop, we're only going to need 300,000 minutes for the swoop. Meaning I have 120,000 minutes left over. It takes 20 minutes for every Rufus sweatshirt. So I take the 120,000 divided by that. Okay, so if demand, the max demand for the swoop sweatshirts was 50,000, we would make all 50,000 of those that we could. Okay, and then when we got done, we would take our remaining time and make as many Rufus sweatshirts as we could. Okay, and if it wanted the contribution margin for that, okay, well, we would have 50,000 times 5, which equals 250,000 plus 6,000 Rufus times 15. And 6,000 times 15 equals, what's it on here somewhere? 90,000. So our total here would just be 340,000. As you can see, it does not reach that 350,000. And I did even one further. So I said, well, what if it was 60,000? Okay, I don't have room to write it up on here, but if it was 60,000 of these, then we would get a contribution margin to be 345,000. Okay, because we'd only be able to make 3,000 of the Rufus. 3,000 times 15 is 45. We'd have 60,000 times 5 is 300,000. 300 plus the 45 would be 345. But you can work that out, but you can see you'll never get better than your optimal mix of selling all the Rufus or all the swoop if you have the demand for them. All right, now on to setting some pricing. Here we provide various financial services. We decide to price as jobs at the total variable cost of the jobs plus 15%. So here we had some client. What is variable here? Okay, variable, fixed. So we can ignore that. $170,000 was our total variable cost. If we want to set our price on it, we can take that times 1.15. Right, and it gets us $195,500. Okay, so what I basically did there is they want to charge this, so it'd be 170,000 plus 170,000 times 15%. Now you can work it out the long way. You can do the math. You're gonna find the 170 times the 15% comes out to 25,500. And you're gonna get the same answer either way. I just find it to be a shortcut, because if they want to find something of this cost plus 15%, well, they need it at 115% or 1.15. And finally, our last one here. New manufacturing with new feature, don't drink and dial. Stops you from drunk dialing, probably not a bad idea. Okay, could use that back when I was a little bit younger. All right, we have a target price of 380. We require a 25% profit. So calculate the amount of profit. 385 the price times 25%. We want our profit to equal 95. So what is our target cost? It was 380, not 385. Sorry about that. So we take our price. Oh, that's just like a right cost. Target cost there equals $285. That's part two. Okay, to get our profit, we just take our selling price minus our multiplied by our desired profit to get our profit, and then our price minus the profit gets us our target cost, and that's how you would calculate that. So good luck on homework for your chapter 8 and your chapter 8 quiz. I will be making the chapter 12 videos for you shortly, and it won't be too much longer, and you'll be ready for exam 2. Keep up the hard work. I know these 5 week classes can be a little trying, a little unbearable at times. I appreciate all that you're doing. Keep it up. You'll be done before you know it.